When you download and install Java from Oracle, you're installing a number of development tools. The package is called the Java SE Development Kit, or JDK, and it includes the runtime, a compiler, and many other tools. The first tool you'll be using is the compiler. It's an application called Java-C, and the name of the application will be the same regardless of whether you're working on Mac, Windows, Linux, or any other operating system. When you run Java-C, you provide it with the names of your source code files, and the resulting output will be a set of bytecode files. To run an application, you use the command Java. Again, it looks the same on any operating system. When you run the Java command, you'll provide it with the name of the class that you want to start with. I'll show you an example of that in a few moments. The JDK also includes many other tools. The jar tool lets you package up your applications. A complete Java application will typically consist of many classes, and when you compile the classes, you end up with a whole bunch of files. But it's a lot more convenient to deliver the application as a single file, and so you use the jar application to do that packaging. When you package up the files, you end up with an archive file in zip format, but with the file extension of .jar. The JavaDoc application lets you create documentation based on comments in your source code. I'll show you how to use this in a later video in the series. And there are many other command line tools that are a part of the JDK. So how do you get started? Well, your Java applications are built in source code files that are pure text files. You can create these text files in any text editor, although I'll be using the Eclipse integrated development environment throughout this course. Here's a classic Hello World application. If you've worked in other programming languages, you might be accustomed to Hello World applications being just a single line of code. That's not the case in Java. In Java, everything is encapsulated in a class of some kind, including your startup code. So this bit of code that I have on the screen represents the simplest possible Java application. The first line of code is called the package declaration. It indicates the location of the source code file within your project. The package declaration is typically a dot-separated string. The beginning of the package, frequently, is your domain name in reverse order, so lynda.com might become com.lynda, and then the rest of the package indicates what type of application it might be within your organization. The next line of code is called the class declaration. If you create a file called helloworld.java, it can contain one public class, and the name of the class must match the name of the file. So the helloworld.java file contains a public class named Hello World. And notice they match exactly. Java is a case-sensitive language, and you must match these strings precisely. Within the class, there's something called a main method. When you run a Java application from the command line, Java will look for this particular method and execute it automatically. The name of the method or function must be main, lowercase. And the three keywords previous to the function name, public, static, and void, are also required. I'll explain what they mean later on. The main method must receive something called an argument, and it must be an array of strings. This allows you to pass in information to the application as you run it from the command line. We call that the args argument. Finally, within the main method, you place your executable code. This application simply outputs the text Hello World to the command line using the command system.out.println or printline. Notice that this string is ended with a semicolon. The semicolon is like a period in English. It means this is the end of the statement. So system.out.println Hello World means output the string Hello World to the command line. So you create that source code file, and you place it somewhere in your project folder. Now in this case, I had declared a package named com.lynda.java training, and so I have to place the source code file in an equivalent subfolder structure. If Hello World is the name of my project folder, then com/lynda/java training is my package folder, matching the dot-separated package as declared in the source code. The name of the file, as I've indicated before, is helloworld.java. The .java extension is required in all of your source code files. To actually compile that file, I would start at the project directory Hello World. I would execute the javac command, and I'd reference the Java source code file, Hello World. Notice that I'm prefixing the name of the file with a / separated syntax, com/linda/java-training/ and then the name of the file. This screenshot comes from Windows, so I'm using backslashes, but if you were working on Mac, you would use /. After compilation, you end up with a new file. The original source code file was helloworld.java. The resulting compiled file is helloworld.class. The .class file is your bytecode file, and because this is an application that only has the single class, that .class file comprises your entire application. So in fact, when you're delivering the application, you don't have to deliver the .java file. You only deliver the classes. Now, to run the application from the command line, I would use the Java command. I would once again start in the project directory, Hello World, and I'd call the class using .separated syntax, just like the package was declared in the source code, com.linda.java-training.helloworld. And notice that when I run the application, I'm not referencing the file extension .class. I'm only referencing the class name, Hello World. The application runs, and the resulting output appears in the console. So that's a look at basic Java syntax and how you would compile and run a very simple application from the command line. Now, throughout the rest of the course, I'll be showing you how to do this in the integrated development environment called Eclipse. And for the most part, you'll be protected from compiling and running directly from the command line, but it's important to know that if you want to work in this way, you certainly can. So once you've learned how to work in Java, where can you use it? Well, Java is implemented in many environments and used for many different kinds of applications. You can use Java for desktop applications, either actually installed on the desktop or delivered through browsers as Java applets embedded in HTML pages. These are called graphical Java applications, and they use libraries called Swing and AWT to build their visual presentation. You can also use Java to build dynamic web applications, that is, applications that are delivered to the browser as HTML, dynamically generated at runtime on a server. These are sometimes called J2EE or simply Java Enterprise Edition applications, and they're executed within server environments such as Tomcat from Apache or JBoss. The code is written using models called servlets and Java server pages. It's exactly the same language as you might use on the desktop, but it's simply modeled a little bit differently. And one of the most popular recent uses of Java is on mobile devices. The Google Android environment uses its own compiler called Dalvik and tools provided by Google that run in Eclipse to build applications that run on Android phones and tablets. The BlackBerry operating system also uses Java, so you can use Java to write applications that run on BlackBerry phones. And you can use Java in many other mobile environments as well. You can, in fact, use Java to build all sorts of applications: games, mobile apps, cloud computing applications, distributed systems, databases, websites, embedded systems, image management, enterprise information management, and many more. So, now that you've had a sense of how Java is architected, its history, its principles, its syntax, and how you compile and run Java applications, it's time to get started with installing Java and writing your own code.